My name's Al Strainer. I'm a site test conductor with the Space Shuttle Endeavour and second generation space worker. Our job is getting her ready and spaceflight worthy from the orbiter processing facility.
There are thousands upon thousands of individual tiles on the space shuttle. We inspect every one of those. The tires, the main gear, come off. The brakes they come off and are refurbished and re-inspected, reinstalled.
5, 6, 7, 8, 9, 10, 11. Okay, that's it.
Lower surface tiles can protect up to 2,500 degrees. It is sometimes hard to believe that it protects it like it does. It's strictly real thin aluminum underneath, that's all it is.
113, 6.
It's a giant jigsaw puzzle that has 35,000 different shapes and sizes of tiles.
Next row. 12, 20.
Every landing when the bird comes in, we check for meteor strikes, scratches that may occur. The end of your hair, if you looked at it, that's the size that we look for on the window. And you have to locate every one. We inspect it, and then the technicians come in and clean it behind us so the astronauts can see for the next mission. One window, an inspection would take about 2 to 3 days. Polishing would take 2 shifts. You have to scrub on 8 hours. If there's a certain amount of damage within a specified area on the window, they have to pull it out or send it back to pointing.
I'm blessed. I get to walk away from my desk and look at a spaceship. My father worked out here, Gemini, Apollo, and the star of the shuttle. It's always been very admirable to help put men in space.
If anything, I think NASA has failed to communicate how really complicated it is to do spaceflight. It's certainly not American Airlines running on some timetable to New York. It's an enormous challenge to get one of these things off the ground. I'm always amazed that it works at all, you know, and that's from being inside of it.
So we're gonna have to pull the line back out. The alignment didn't make it, so
Yeah.
pull the line back out.
-11.
The shuttle main engines are high-performance engines operated at 104% of their design capabilities, and so we're having to look at the turbo pumps and pieces of the engine after each mission and often replace them.
Right there. That's what I'm thinking is what we're seeing.
The aft compartment of the shuttle is kind of like a maze. I refer to it as a space-rated Swiss Family Robinson's treehouse. The paradoxes there are unbelievable. You have a titanium thrust structure that holds thousands and thousands and thousands of pounds of thrust. Right next to it, you have a phenomenal amount of plumbing and wiring, and it's all very sensitive and very delicate. Can you imagine being back here during an orbital liftoff? You've got gallons and thousands of gallons of liquid oxygen flowing through this feed line, and it's coming from the external tank disconnect located down there. Everything that we do down here has to be perfect, because when you go into orbit, there's no way of getting back there and working on anything. Then she rolls out of the orbiter processing facility. We take it to the VAB, which is the Vehicle Assembly Building, the big building.
And then it's brought to this 48-story immense modern cathedral that was designed for the Saturn V rocket, which was much bigger than the shuttle stack. And then it's taken with a crane and grabbed by the nose and hauled vertical, and then moved over and mated with its external tank, its expendable fuel tank, and the solid rockets, which themselves have been prepared for several months for this mating.
Although it appears we go overboard in some cases and things do seem to be laborious, there's a lot of thought process put into that. You know, the old carpenter's saw, you measure twice and cut once.
Clearly, the shuttle was sold on some false promises, and the most important of those false promises is that it would be routine and inexpensive.
Not only were there no savings, but the space shuttle has been fabulously more expensive than the expendable launch vehicles it replaced.
And it was very clear to many people from the very beginning that this was going to be a cost-ineffective white elephant. And in fact, it has been.
I wish there was an easy answer to how you ignite people's re-interest in the exciting and tremendous idea of man going into space. When you think back on the old days, and one of the things that JFK was famous for having said, and that is, you take your very best hat and you wear it down the street, and when you come to a wall you know you can't scale, you throw it over. And then you just try to go get it. Try to get it back because you know you can if it means enough to you, and it's the way you find out how much you really can do.
That you're actually carrying about $3 billion worth of national assets, you know, here on our shoulders, you know, while we're going to the pad. It's pretty mind-boggling. But to me, the more incredible part about the crawler is when you do dock it up at the pad, the accuracy is down to a 1/16 of an inch that we can stop the crawler at, north, south, east, and west. So even though she may be a clumsy beast, she can really put it on a dime. We are rolling about a mile an hour at this time. We have about an hour and a half left to go to get to the top of the pad. And Hans is running pretty good. I started calling him Hans and Franz after Beastie Boys, and that's where we got it from, was from a Saturday Night Live clip. They used to have characters on it called Hans and Franz, and they were here to pump you up, and that's what we do.
When we developed the shuttle, we used the old facilities that had been created for Apollo and adapted them for shuttle. It's very much a cobbling together of budget-driven design compromises that we see.
It was a learning process of old technology and new technology put together to try to define and place how we can go on from here to do it more efficiently.
There are something like 30,000 people involved in getting a shuttle ready for launch and launching it. That's no way to make it cheap. The idea that we could have done that somehow for $10 million a throw just boggles the mind when you see what actually happens.
NASA was given a very difficult job, and technically NASA performed. The shuttle is too expensive to operate. We've got to find much faster, cheaper ways of doing it.
Well, my name is Robin Brack. I work in the crew escape department. And what we do in crew escape is we take care of all the life support equipment that the astronauts need to fly in space. What we look for in the equipment is to make sure that everything that's in the suit mechanically is functioning properly. So if they had a rapid decompression, let's say, the suit would do its job, save the crewman's life, and they would be able to survive. If an astronaut was getting ready for launch, the first thing he would do was he'd put on his diaper. This diaper is just like a Pampers diaper that a little kid would wear, except it's made for big adults. The next thing what he would do is put on his Patagonia underwear. It's a liquid-cooled underwear.
Lay on your back on the floor with your feet above your head for 5.5 hours. When you're on the launch pad out there, I guarantee you, in short order, you'll wish you were wearing a diaper if you have no other means of relieving yourself. We pull on a anti-G suit, and then over that comes the rest of the spacesuit, which is a pressure suit, essentially. We call it the pumpkin suit, right? It's orange, and international orange for rescue, so they can find you if you ever had to bail out. Come on up. Okay.
Feel good?
Feel good.
Okay, Green Apple, you got charged. You're saving somebody's life, and if something should happen, and it's very important.
Inside the parachute, besides the parachutes, are life raft and survival water and radios and everything you'd need to survive in the ocean, hopefully long enough for them to find you. And there are scenarios you can paint where the shuttle comes down intact but can't make a landing strip, and you essentially were writing the crew off in that case previously, but now we have the option to at least bail out. Feels super. Thanks. You're not going to fly, huh?
No, not tonight.
Coward. I thought, well, the shuttle will just be another easy system. You know, within a matter of weeks, a couple weeks after getting the books on it, I'll study it up and I'll be ready to go fly it. And it turned out to be not the case.
The aircraft is a highly modified Gulfstream II. Flies almost exactly like the Space Shuttle. The performance has been modified so it descends like the Space Shuttle. The same descent rate, the same type of drag. It's very, very important training for shuttle pilots because the shuttle is a very difficult aircraft to fly, and it's very different from any other airplane that I've flown in my life.
We have an instructor pilot in the right seat who gets the airplane up to about 35,000 feet. And at that point, we put the engines into reverse, and you're rapidly on your way down to Earth at the rate of 22,000 feet a minute.
Commercial airlines, you come in at about a 2% glide angle coming down. Shuttle comes in 22%. That's going downhill real fast.
Before you fly as a commander, you typically have about 1,000 approaches, and you get about 10 a flight, so about 100 flights in the shuttle training aircraft.
It's a real nice process coming back. When you hit the Earth's atmosphere, you're doing Mach 25 or about 18,000 miles an hour. And the way you slow down is by pancaking or sort of speed braking the orbiter into the Earth's atmosphere. And that's why the tile are so critical on the bottom, is that they absorb that heat.
Without a doubt, the hardest part is what I do, and what I enjoy doing. Is it worth the risk to my family? Because I love my family dearly, and I have 3 small daughters, you know, a 4-year-old, a 2-year-old, and a 6-month-old now, and when you kiss them goodbye 7 days prior to your scheduled launch as you go into quarantine, because you're not allowed to see your children in quarantine, that's a difficult night. Very difficult.
I asked Danny a couple of weeks before flight, are you excited about your daddy going up in space? And she said, no. And I said, well, why not? She says, it might blow up. So Challenger is still there in the forefront, I think.
That's what I think of every time it goes up. And the booster separation really bothers me. And my children, you know, laugh at me when we have a joke afterwards, but I jump every time.
Seeing that shuttle going up is like amazing to me because you're watching all this power just push this tremendous shuttle into the air, and it starts to hover at first, and it seems like that's the only thing you care about in the world right now.
It's an incredibly dangerous business. You're turning loose so much energy in such a short period of time. You're using such sophisticated techniques and procedures and equipment. We're going to lose people. We're going to lose more people. I think it's only through the dedication of all the fine folks who work in this business we haven't lost more already.
As the time for launch approaches, things get more critical. My mind is reviewing all the things that could be trouble spots. Did we cover everything adequately? Did we check everything? Did we watch everything? Are we really ready? The bottom line is we cannot afford another Challenger accident.
Okay, we've got a main engine flash in the plume of main engine number 1. Do you notice any kind of contaminant in the exhaust plume that would cause that?
I didn't see anything obvious. However, I wonder if it's related to that event we saw just prior to this.
And so if it means checking something another time, another 10 times, another 100 times to make sure it's going to operate properly and not jeopardize the crew or the vehicle, we will do that. The film analysis is like a detective story. We use different formats to piece together the event. For example, a small leak, should it occur, or a piece of hardware falling off the shuttle. A wide-angle view gives us more time to plot a trajectory, to watch the
the rotation and characteristics of that piece falling away from the vehicle. We have approximately 80 of these type cameras positioned around the launch pad. They are designed to look at the vehicle from every possible angle so that we can ascertain the condition of the vehicle during the hazardous fueling operation. After the fueling is complete, we come out here with a team called the ICE team. We've only got 2 hours to look at every square inch on this vehicle and pronounce it ready for launch. We are well aware that there's over 2 million pounds of solid rocket fuel in the boosters and over 500,000 gallons of cryogenic fuel in the external tanks. So it is a hazardous operation. There is potential for major problems there should anything ever occur. So all the team members are volunteers. Actually strikes me as a living, breathing entity. It makes sound. There is the hissing of purge gases escaping, the popping of valves opening and closing, the rumble of the burn stack as we burn off the excess hydrogen. And so you get this impression that it is ready to go and it's catching its breath, waiting to jump off the pad.
My name is Al Sofji. I'm the shuttle test director at Kennedy Space Center, and my prime function is to lead the launch team during the launch countdown process, which starts 3.5 days before the actual liftoff. The final hours of launch start approximately 8 to 10 hours before launch, and we come in, we check the weather, make sure we have good weather. We check with all of our systems and all of our support areas around the world and make sure that no one has a problem that would prevent us from tanking or launching.
When you get ready to launch the shuttle from the Kennedy Space Center, you have several emergency landing fields on the other side of the Atlantic Ocean, 6 time zones away. And so if it gets too late in Florida, that means it's already, particularly in the winter, dark in Spain or on the coast of Africa. And so you can cancel a launch because your emergency landing sites are in darkness.
There is no actual button that someone pushes. We have what we call a ground launch sequencer, which is effectively a computer program that takes us down through the last minutes of launch. It can stop itself if it detects a problem, or anyone in the firing room can request a hold if they see a problem.
Well, I'm Bob Seek. I'm the launch director for the Space Shuttle. My responsibility is to make sure that we don't get launch fever, we don't get carried away. In this pyramid of reaching the final go for launch, everyone is polled where they have to indicate that they are really go to proceed.
NASA Test Director, this is ICE Team, Channel 232. We're complete on the FSS 215-foot level. Everything looks fine.
If I'm comfortable that there's nothing out there that's bugging anybody, then it's fairly easy to give the go-ahead to launch.
In 3 Tagen soll die amerikanische Raumfähre Endeavour von Cape Canaveral zu einer 9-tägigen Reise ins All aufbrechen. Der Flug des Space Shuttles steht im Dienste der Umwelterkundung. Mit an Bord ist erstmals ein deutsch-italienisches Fernerkundungssystem, das die Radarbeobachtung der Erde aus dem All revolutionieren könnte.
Dies ist eine Satellitenaufnahme des brasilianischen Regenwaldes. Die roten Flächen zeigen die Gebiete, in denen der Wald bereits abgeholzt wurde. Ein Beweis für die Zerstörung, der mit normalen Fotos kaum zu führen wäre. Dass die Menschen nicht mehr ins All starten, um ferne Planeten zu erkunden, sondern sich auf die Mission zur Erde begeben, ist nichts Neues mehr. Der europäische Radarsatellit EAS-1 liefert seit Jahren aufschlussreiche Daten, vor allem über die Ozeane. Das neue deutsch-italienische Fernerkundungsradar IXA, das am 7. April mit der Raumfähre Endeavour die Reise ins All antreten soll, ist besonders für Untersuchungen der Landoberfläche und der Vegetation ausgelegt. Die Daten sollen bei der Deutschen Forschungsanstalt für Luft- und Raumfahrt in Oberpfaffenhofen aufgefangen werden. Dort hat das Deutsche Fernerkundungsdatenzentrum, kurz DFD, seinen Sitz. Mit an Bord der Endeavour wird auch ein US-Radarsystem sein. Beide Systeme sollen die gleichen Gebiete beobachten, jedoch mit unterschiedlicher Wellenlänge. Von dieser Kombination erwarten sich die Experten eine nie gekannte Datenfülle und Qualität der Information, vergleichbar mit dem Sprung von der Schwarz-Weiß zur Farbfotografie. Daten, die 20.000 dicke Lexikonbände füllen würden, werden von dieser Mission erwartet. Deren Auswertung dauert, doch in Oberpfaffenhofen hat man ein Gerät entwickelt, das einen sogenannten Quick Look gleich nach Ankunft der Daten erlaubt. Einen ersten, schnellen Blick. Hochwertige Bilder wie diese Animation des Ozonloches bringt erst die Verarbeitung der Daten im Computerlabor. Die Experten der Bildverarbeitung müssen keine Angst haben, dass eine Wolkendecke die Sicht versperrt. Der IXA ist kein optisches, sondern ein Radarsystem und daher für jedes Wetter geeignet. Das X steht für die Frequenz von 9,6 GHz, auf der gesendet wird. SAR ist die Abkürzung für Synthetic Aperture Radar, eine Radarantenne, die synthetisch, also durch ein Rechenverfahren künstlich vergrößert wird und damit genauere Daten liefert. Daten zu Gebieten, die schon frühere Satelliten beobachteten, so zum Beispiel das Mittelmeer und seine Temperaturwerte. Dieses Bild zeigt den Vegetationsindex in Mitteleuropa und verbessert damit die Präzision von Erntevorhersagen. Vom neuen Radar IXA erhofft man sich hier noch eine bessere Auflösung. Oder ein Blick auf Bangladesch und seine durch Überschwemmung gefährdeten Gebiete. Alles Bilder, die von den Fernerkundungssatelliten digital übermittelt wurden. Ältere Satelliten schicken immer noch analoge Bilder. Um sie in den digitalen Datenfluss mit einzubringen, gibt es jetzt einen neuen, von der Deutschen Forschungsanstalt für Luft- und Raumfahrt entwickelten Scanner, mit dessen Hilfe die Bilder digitalisiert werden können. Für diese ungeheuren Datenmengen braucht man natürlich Speicherkapazitäten. Dieser Massenspeicher wird in seinem Inneren von einem Roboter bedient, der mit der 2000-fachen Leistung eines PC die eingelegten Platten auswechselt, wie eine Musikbox. Die Wissenschaftler haben diesem Computer folgerichtig den Namen Jukebox gegeben. Das Projekt IXA wird neue Erkenntnisse bringen, noch bessere Bilder liefern und vielleicht den Menschen wieder etwas mehr ins Bewusstsein rücken, dass der Planet Erde schützenswert und schön ist. Und das nicht nur auf Satellitenfotos.
Endeavour's 6-person crew will work in 2 teams around the clock during their 10 days in space. They plan to take 14,000 photographs of Earth as the radar sends its images of the planet.
Everybody's excited about taking pictures. We've been training for a long time and working hard at it.
The radar will be tested over thick vegetation, ice packs, wetlands, and deserts. It'll also be used to detect movement in the oceans. This same system will fly on an August shuttle mission to determine how loss of forests affects local ecology. Former CIA engineer Tom Jones will be flying both this week and on the follow-up trip in August.
And, I think we're going to learn from the continuity that I can provide from this flight to the next a lot about how to operate the radar and do the crew job more efficiently on board. And I think that's the big payoff in doing this. So it was a good, smart decision personally from my point of view because...
Jones makes history by flying 2 shuttle missions so close together. As NASA continues fighting in Congress for enough money to keep the shuttle flying, managers have their fingers crossed that Endeavour can get off the ground on schedule and do everything it's supposed to do once it reaches orbit. John Holloman, CNN, Capitol Hill.
As it counts down toward tomorrow's scheduled launch of the Space Shuttle Endeavour, forecasters are worried about an approaching cold front, which is bringing low clouds, high wind, and rain with it. And any one of those could delay liftoff. NASA says there is about a 60% chance that one will. On board Endeavour is the most sophisticated radar equipment ever designed for Earth monitoring. It'll be used to scan environmentally sensitive areas of the Earth. Blastoff is scheduled for 8:06 a.m. Eastern, and CNN will cover it live if it happens.
Hopefully to start your weekend. Still clear on the East Coast. Looks good. The storm system well to the west into the plains. That'll be making some rain and some snow. Then finally into the western Great Lakes. Both the Canadian and U.S. sides will see a little bit of snow. North and west, still we have snow, springtime stuff, but it's going to stay with us. On into Friday evening, more snow showers, Great Lakes region. On up into Canada, the western provinces, north and western United States. That's what we'll be talking about at least for the next day or so, because that's where most of the commotion is. All the while now on the East Coast, mainly in the clear. Detailed.
Endeavour soll heute um 14:06 Uhr mitteleuropäischer Sommerzeit in Cape Canaveral zu einem Flug ins All starten. Die 9-tägige Mission dient allein der Umweltforschung. Mit Hilfe moderner Radarinstrumente, die unter anderem auch in Deutschland gebaut wurden, sollen Landschaften und Inseln kartografisch erfasst werden. NTV berichtet live von dem Start der Raumfähre.
To use a sophisticated radar system to study the Earth. When the shuttle does take off, we will bring you live coverage of it here on CNN International.
Members waited patiently on board the shuttle for more than 2 hours this morning, while officials watched the weather and decided what to do. Endeavour is carrying what NASA says is the finest space radar ever designed for environmental research, the focus of the 9-day mission.
Then when you get to countdown, it never gets to be routine. It never gets to be old hat. You can't help as a human being not to have that nagging feeling that, have you ever done enough? You know, have you ever really done enough?
At this point, our forecasters are predicting only a 20% chance of violating our launch constraints at that particular time, and only a 20% chance of violating...
Good morning.
Good morning.
Thank you, Mr. Talon. Have a good day.
Thank you. You all have a good evening.
Okay.
At
Get it up.
Time,
All right.
We expect to have some scattered clouds.
Everything else is on schedule. We'll launch at 8:07 hours. The window extends to 13:09. Let's hope it goes on time.
We've loaded the tank and we're replenishing it, keeping up with what we call the heat leak, because it's not a perfect thermos bottle. So we have to keep adding a couple hundred gallons a minute of hydrogen and oxygen to the tank.
This is Shuttle Launch Control at T-minus 3 hours and holding. Crew preparing to have the mission cape with the STS-59 mission emblem on it. This is Shuttle Launch Control. Approximately 1 hour and 11 minutes remaining in this built-in hole. The ice team is at the pad doing their inspections at this time and is reporting some limited ice found on the external tank. Commander C. Gutierrez, pilot Kevin Chilton, and there's our payload commander Linda Godwin.
It is a strange thing. You do all this sophisticated training, you have all these people who do all this high-tech preparation, but it really does come down to a few people who take you in a bus out to the launch pad. They do strap you into this vehicle. And then you know that anybody in their right mind gets way the hell back away from this thing, at least 3 miles, and leaves you alone out there with all of this high explosives, and makes you think very hard about doing this job.
Now on the way to launch pad 39A in Custom.
There's ceremony, and I think it's a ceremony that we need as human beings. We need ceremony, and I think in this case, these are emissaries that we're sending out into space.
Yeah,
Yeah, well, and the excitement in the bus kind of builds, too, as we're coming down. I can remember going out and people saying, okay, one more corner. Oh, you know, look at that. Isn't it marvelous? Normally, you're used to arriving at the pad and finding all these workers, you know, scurrying all over the place, readying the vehicle for flight or readying the pad. Suddenly, you get out there, and there's just the 6 of you on the crew and the 6 members of the team that are going to help strap you in and do the final hatch closing. And that's it. Those are the only human beings out there in this big, beautiful rocket ship.
We're at the 195-foot level of the tower. The crew module's right here. The external tank is not more than 20 feet to this side, and there's a solid rocket booster that's loaded and ready to go that's right next to it. So we're right in the middle of it. All of that's full, and we've got about 1 million gallons of liquid hydrogen and liquid oxygen right there ready to go. So you're one of a dozen people that you're out here, and everybody else is 4 miles away.
OTC Endeavour. Go ahead. Yeah, we'd like to confirm with Houston that RTLS is nominal waypoint and runway 36.
This is Shuttle Launch Control at T-minus 2 hours, 6 minutes. Mission Specialist Tom Jones is now being prepared for first boarding Endeavour.
There you go. Okay, we got you now. At this point, you're kind of numb to the whole thing, I think. You're just excited a bit and looking forward to getting in and strapped in and settled down. And it's a bit uncomfortable like this. Kind of laying on some valves in the back of the suit. But it's not too bad for the first hour and a half or two. As you approach a little after that, you start getting a little uncomfortable with sometimes back pain. So the quickest way to get comfortable is to launch, you know. If you scrub, it takes them about 40 minutes to get back out here and open the hatch and take you back. But if you launch, it's only 8.5 minutes to 0G, so that's the most comfortable end of the deal. Get into that one, I'll put your booties over there.
OPCC, OPC. Go ahead. Yeah, we'd like you to turn the portable O2 back on. Copy.
Good morning. How long have you all been cooking this morning? The beans have become such a trademark to what we do here. It's like fish and loaves. There couldn't have been enough to go around, and it grew and it grew, and now it's a tradition, and we feel like the beans are part of our luck, and the beans are also a part of the celebration.
This is Shuttle Launch Control. Astronaut Coop Kid, both shuttle training aircraft. He can evaluate the actual weather conditions around the runway. Definitely waiting for his report before we commit to launch this morning.
I think that people become addicted. They go back time and again to watch them, you know. The people who live down there get up at all hours of the day or night when there's a bird about to go. You know, all the cars stop and watch it go.
The observance, it's almost like people going to watch the king bathe.
It is kind of a religion. I mean, it's like people are watching human beings leave the earth. And it's a process that they want to be a part of.
It's kind of like our Super Bowl day. And we're all hoping and praying and a little bit nervous. You have a little bit more butterflies. You're looking people in the eye that's worked with you. Everybody's scanning what they did over the last 90 days.
Launch Director Bob Seek has just had another conversation with the launch weather officer. There is still a possibility that we will have a launch today.
Not a 747 with wings out there tied to those rocket motors. And when everything's right, we'll launch.
It's disappointing when you don't get one off the ground. You really want to get one off the ground. And we're real happy when it's just the weather, because that's out of our control. We know we did our job right.
Okay, let's go buy some water.
If in the first couple of minutes something goes wrong, where you can jettison the fuel tanks, jettison the solid rockets, and try to fly back for an emergency landing at the Cape. And you certainly don't want cloud cover over the landing strip under those conditions.
Our forecast is still no-go due to crosswinds. OBS have seen peaks up to 20 knots on the crosswind.
Bob, I support their decision, and we've exceeded the crew on back time by a few minutes already, and let's recycle for tomorrow.
And that's all happening at the LCC over here, the Launch Control Center.
Give you a go.
Nice try, everybody, and our recycle for tomorrow will be to hit a 7:05. Local time, beginning of the window, 11:05 GMT.
That's it, guys. That's the business. That's the business we're in.
When it scrubs,
Hello, my friend.
I know it sounds selfish, but there's a lot of work to do for a scrub turnaround for 24 hours.
What we'll do right now is we'll head back into the suit-up room and we'll de-suit them, and then the work begins. We've got about 6 more hours of work, and then it's off to get some sleep and turn and burn for tomorrow morning.
Maybe next time.
The countdown's underway for the liftoff of the U.S. Space Shuttle Endeavour in a matter of minutes. You see the Endeavour on its launch pad in Florida as it's set to start the 9-day mission to assess the Earth's environment from space. We can now join CNN's domestic network for live coverage.
Joins us now with details on the launch and the mission. John?
Jonathan, good morning. The Shuttle Endeavour is ready to go on Launch Pad 39A at the Kennedy Space Center in Florida, scheduled to leave the Earth in a couple of minutes for a 9-day, 5-hour mission to map planet Earth. The shuttle's cargo bay filled with exotic radar equipment, which will give ground-based scientists and the rest of us images of 5% of the Earth's surface. The ultimate goal of Mission to Planet Earth is to look at the entire planet from space with an eye towards solving some of the ecological problems that cause trouble down here. I spent part of this week with mission scientists, and they say they hope to find out which changes in the Earth's ecology are caused by people and which are caused by nature. There are 3 separate radar systems in the cargo bay. Some will look at the Earth's surface, and some can even see through clouds and down below the surface of the water and ice and some land masses, particularly deserts. The picture that you're seeing right now is, of course, the skies over Florida. Yesterday, they were very, very cloudy, preventing the launch. And right now, as you can see, there's a band of clouds. But in general, the skies are clear. There are no weather constraints to launch, as NASA calls them. And with about 90 seconds to go before the liftoff, you can see the Shuttle Endeavour there on the launch pad. You can see also the winds that are blowing at about 21 miles an hour. As long as they don't get up to 25 miles an hour, the shuttle will be able to lift off on schedule, and there's no possibility, no potential for that to happen, according to the ground controllers. Everything in readiness for the launch, as long as the equipment aboard Endeavour continues to work very, very well. Back to the mission for a little bit. There's a piece of equipment in the cargo bay which will measure the amount of carbon monoxide in the Earth's atmosphere. It'll help scientists determine how much of the polluted air from the northern hemisphere drifts down to the southern half of the globe. The astronauts will be working around the clock in 2 shifts as the shuttle passes over for a particular landmass and the radar beams down to study it. In the final half minute of the countdown, we'll continue to listen to NASA commentator George Diller until the most important point in this mission, when the pilot says go at the throttle up. So let's listen.
Endeavour's computer is now controlling.
20.
Sound suppression water system being activated.
10. Main engine start.
7, 6, main engine start. 5, 4, 3, 2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
Roger, roll, Endeavour. Houston now controlling, Endeavour rolling on course for 57 degree inclination, 120 nautical mile orbit. Endeavour already traveling about 300 miles an hour on a course that will have it go northeast side of the Atlantic Ocean, parallel to the eastern seaboard of the United States. Endeavour's three main engines now back at 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. Endeavour speed now 1,000 miles an hour, 5 miles downrange.
Endeavour, go with throttle up. Roger, go with throttle up.
Altitude 9 miles. Three engines now back at full throttle. 1.5 minutes since launch, Endeavour's already burned more than 2.25 million pounds of propellant and weighs less than half of what it did at liftoff.
Well, in about the next 60 seconds, another milestone in the career of this space shuttle crew will be passed, as the two huge solid rocket boosters that are providing most of the thrust to get it into orbit are jettisoned from the side of the shuttle. As long as those rockets are there, there is still a considerable amount of danger to the crew on this mission. And we'll watch with great interest to make sure those rockets burn out on schedule and separate. There they go. And I've talked to astronauts who were sitting in the shuttle for one of these launches, and they say when that moment comes, everybody aboard breathes a sigh of relief. Because those two rockets really, they think, are among the most dangerous parts of the shuttle system. So what's going to happen for the next 6 minutes? The shuttle will continue to go into orbit using the power of the three main engines there at the base of the spaceship. After it reaches orbit, the payload bay doors will be opened within a matter of 30 or 40 minutes, and the astronauts will begin their mission to planet Earth. Over the next 9 days, we are going to see some pictures of this planet that are unlike any that human beings have seen before. It should be quite a 9 days. I'll be here with you, and we'll continue to watch throughout the 9 days. John Holloman, CNN, reporting.
You're watching live pictures of the Space Shuttle Endeavour as it was launched.
6, main engine start, 5, 4, 3, 2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
6 astronauts are on board the 9-day flight to test an advanced radar system designed to monitor the Earth's environment. Also along for the ride on the Space Shuttle Endeavour, a device for measuring the so-called greenhouse effect.
Cape Canaveral, kurz nach 13 Uhr mitteleuropäischer Sommerzeit. Zweiter Startversuch der Endeavour innerhalb von 24 Stunden. Die 6 Astronauten, 5 Männer und eine Frau sollen mindestens 9 Tage im All bleiben. Die sogenannte Mission zum Planeten Erde steht ganz im Zeichen des Umweltschutzes. Die Astronauten werden aus einer Entfernung von 222 Kilometern rund 14.000 Bilder von der Erde aufnehmen. Außerdem sollen moderne Radarinstrumente unter anderem die Alpen, die Anden und die Sahara kartografieren.
Gearing up for a 9-day environmental mission in space. 5 men and 1 woman will sample the Earth's atmosphere using a new space radar lab. Bad weather postponed Friday's scheduled launch until this morning.
7, 6.
The Endeavour was launched shortly after dawn, providing beautiful pictures of a shuttle blasting into orbit against the background of a Florida sunrise.
3, 2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
As soon as the shuttle was safely in orbit, mission managers gloated over their success.
It was a great effort, and the results of that are, of course, we now have an orbiter and a crew and a payload on orbit.
We adjusted the time so as to be just almost picture perfect in terms of effect with the sun just coming over the horizon.
The astronauts enjoyed the ride.
Taco, this sunrise is beautiful. This is an incredible way to commute to work.
When the payload bay doors were opened, you could see the $366 million Earth mapping radar system with the object of its flight in the background. Over the next 9 days, the radar will send back images of the Earth from the vantage point of 120 miles up. In addition to TV pictures of the ground, the radar will be able to look through clouds and under desert and ice on the surface. The shuttle will fly over mountains, volcanoes, lush forests, and the environmentally threatened Amazon rainforest, while teams on the ground confirm what the radar is checking from the sky. It's the highlight of NASA's mission to planet Earth. Endeavour is scheduled to return to the Kennedy Space Center on April 18th, but if supplies hold out, they could stay up an extra day. John Holloman, CNN reporting.
And that's World News for now. We'll have a...
KSC area is clear for launch. Copy.
And word that the blast danger area has been cleared of all personnel for the launch this morning. Still targeting 7:05 for our liftoff time.
Yeah, it's clearing up nicely.
Now checking the flight controls of Endeavour. Final check before liftoff of the rudder and ailerons. We'll be checking the main engines.
Want to do it again?
Yeah.
Are you happy? Okay, and remember, walk out this way. Go that way, huh? Okay.
Hej alle KTV-seere. Dagens videopostkort fra USA er faktisk lidt specielt i dag, for jeg står her ved Cape Kennedy.
T-minus 5 minutes.
TLS go for orbiter AQ start. TLT, OTC, perform AQ start.
Work in space.
Good work.
Kevin Chilton now flipping 3 switches in the cockpit to start each of the 3 APUs.
Oh, Black College Union.
T-minus 1 minute. Now turning off the joint heaters on the solid rocket boosters.
Done with this is laid it out.
TLS go for auto sequence start.
Endeavour's computers now controlling.
10. TLS go for main engine start.
7, 6, main engine start. 5, 4, 3, 2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
Speed now 1,000 miles an hour, 5 miles downrange.
Endeavour, go with throttle up. Roger, go with throttle up.
Altitude 9 miles. 3 engines now back at full throttle.
Look at that shadow.
Altitude now 15 miles. Speed 2,100 miles an hour, 15 miles east of the launch pad. Flight controllers standing by for burnout and jettison of the twin solid rockets. Good solid rocket booster separation confirmed. Endeavour now 33 miles northeast of the launch pad. Altitude 30 miles. Speed 2,700 miles an hour.
Endeavour, performance nominal. Copy, performance nominal.
That means now if it loses one engine, it can still make it to Africa.
Speed now 13,600 miles an hour. 600 miles northeast of the Kennedy Space Center.
5,000 miles an hour to go. Really hauls ass in the last.
For speed 16,400 miles an hour.
Yeah, you came on 3,000 right there.
Present to MECO.
The longest 18 minutes in the world that exist from T-minus 9 until main engine shut off. And it's almost hard to breathe during that period of time.
Booster officer confirms the good cutoff of the main engine.
Yes. Yes. All right. We're there. Congratulations. Floating. Yeah. Good job on the engine, buddy.
Nice job. Good job, Mel.
Yeah.
Hey, nice job. Good job, buddy. We're up there. Everything's uphill, we call it.
You worked for months, 2 or 3 months on an orbiter to get it ready, and when the engines light up and it fires off the pad, it's just like you feel it right in your gut. It's absolutely perfect. It's beautiful.
Couldn't be better. I mean, everything worked. No fits, funnies, fails, or falls. Hey, JB.
Well, it's a tradition at least, and when you got something working for you, you don't change it. He's honed in on your beams here. Can't miss him.
Manned access to space, we feel, is on our shoulders. It has to be damn near perfect every time because we can't tolerate a failure. We can't tolerate it. It's a zero-tolerance program.
And I think everybody in NASA realizes that, and no one wants to make the small incremental mistake that puts the space shuttle at risk, not only again for the human tragedy, but also for the enormous political consequences. So this is an agency that lives in fear of making a little mistake and that grinds the wheels to a halt.
I think it is time for the American public to fish or cut bait. Either it wants to go to space or it doesn't. And if it does decide to go to space and it wants to keep people in space, then I think it's got to grow up. And it's got to decide that you take your hits. You pay for this with blood and treasure.
Should we crawl into a cave and assume the prenatal position and say, oh God, I'm so worried about launching a shuttle? NASA cannot live in fear. I tell our people to take risks, do everything possible to make it as safe as possible, but we will not stop flying. We've got to go to the boundary. Now, if America decides if we have a problem to cancel a program because we've lost that ability to take risk, I cry for America, not for NASA.
$366 million radar equipment is supposed to be the most advanced space radar ever built for civilian use. Scientists are hoping it will provide the most detailed monitoring ever of the Earth's environment from orbit.
Die 185 Millionen Dollar teure Anlage, von deutschen und italienischen Wissenschaftlern entwickelt, soll etwa 5% der Erdoberfläche kartografieren. In einer Höhe von 222 Kilometern werden rund 14.000 Bilder aufgenommen. Sie sollen Erkenntnisse über die Beschaffenheit des Meeresbodens in Küstennähe und der Eisbedeckung liefern.
From the CNN International Weather Center. It is windy, has been windy. In a region from Scotland into the Benelux region, we've had reports of winds sustained to 40 or 50 knots. We expect those winds will ease just a bit, but breezy conditions will still persist as an area of low pressure begins to weaken across central and eastern sections of the continent, where there is rain, of course, in the forecast all the way into western Russia. Stay tuned for a complete international weather forecast within the hour.
Weather satellite is up in orbit this morning to help with day-to-day forecasting. The $220 million satellite went up this morning from Cape Canaveral.
Rakete in Cape Canaveral.
Main engine 73 with the goes-on weather satellite.
Sie transportiert einen neuartigen Wettersatelliten ins All. Der $200 Millionen teure Satellit soll genauere Daten über Hurricanes liefern und Katastrophenvorhersagen für Nordamerika deutlich verbessern.
An Endeavour interview, only on CNN International.
The atmosphere is dirtier than NASA scientists had expected. That's the preliminary conclusion from pollution monitoring aboard the orbiting space shuttle Endeavour. Previous shuttle missions had found more pollution in the southern hemisphere because of tree and grassland burning in Africa and South America.
Coming up for our Latin American viewers, El Noticiero CNN Internacional. For everyone else, more world news, including a live interview with an astronaut aboard the US space shuttle Endeavour. She'll be answering questions from you, from viewers around the world, when we return. Stay with us. Joining us now is CNN's John Holloman to talk about the mission and to get a few of your questions answered by shuttle crew member Linda Godwin. John.
Sonny, this is great. Dr. Godwin is the payload commander for the shuttle, and so she's in charge of these dramatic radar systems that are out in the cargo bay. Doctor, it's a pleasure to see you up there today. I don't see how people with long hair manage to keep it together the way you have done this entire mission. We've seen a lot of pictures of you on television during the week. Let me tell you in advance what we've done. We've asked our CNN International viewers from 220 countries around the world to come up with some questions for you. There are a lot of them. I have a stack here of dozens of questions that have been faxed in. Let me start, first of all, while you are flying right now between South America and Africa, we know that the shuttle's radar is mapping the ocean floor. A question that was asked to me just a few minutes ago is, what can you find when you're looking at the ocean floor? How far down can the radar see? And when you're doing this radar mapping, can you find things like underground deposits of oil and things like that when you're flying around?
Probably what you just mentioned at the end is a little beyond the radar's capability, and it's used primarily for mapping the surface of the ocean. You're absolutely right. It does penetrate somewhat into the depths, or at least it sees things on the surface that are indicative of what's below the surface by a few meters. And one of the main reasons for studying the Southern Ocean, as you mentioned, is going on as we speak. It's a very energetic place, evidently, on our planet, and the waves down there are always very, very high. 20 feet is almost average, and sometimes 40 and 50 feet are the kind of waves they see. And so there are tremendous ocean features and phenomena going on down there that contribute to the whole ecosystem of our planet. And so it's a place that we're very interested in learning more about. Now, in some cases where water is very, very shallow, the radar might be able to see all the way to the bottom and perhaps pick out some of the features that you mentioned, although probably not mineral or oil deposits.
There's a report today, based on some of the work you have done, not with the radar, but with the other instrument in there that is checking for pollution, that the Northern Hemisphere appears to be much more polluted than scientists anticipated before this mission started. What can you tell me about that? Have you seen any examples just looking out the windows?
I tell you two things that we've seen. We get to see fires up here at night, and that generally depends on it being dark, of course, outside our windows. And because of our orbit and launch time, for us, darkness has generally been in the southern hemisphere. So in terms of burning biomass, organic materials, we have not noted that in the northern hemisphere. However, we have been flying over parts of the north that are very ice and snow covered, so we could infer that there's a lot of fossil fuel burning going on there because it is very cold right now, rather extreme temperatures. And we have been very lucky in that they've been able to fax some data up to us that shows where the maps data has been taken and which areas have been more intense carbon monoxide than others, and it does reflect exactly what you said. And I guess visually as a crew, we can't say that we've seen anything in the far northern hemispheres to back that up, except for the fact that it is winter up there. We have noted there's been strong correlation between the maps data that we've received and where we have reported some fires in the southern hemisphere. And so I think it takes a while to understand the big picture. And from what we understand from talking to the scientists, it also seems like a lot of this can be naturally produced over the world, maybe as much as 50% of the total concentration. So I think we have a long way to go in understanding the whole global chemistry problem. But I think the nice thing about this mission is we're bringing back something that hopefully will help contribute to the answer.
Yeah, we had a viewer in the Netherlands who asked a question by fax earlier today about why the radar couldn't do its job without astronauts present. Why is it important that you and your 5 colleagues are in orbit along with the radar?
A very good question, and let me jump just a bit to the future first and say that in the future we hope it actually does that and it flies on its own, because this is a great system and I think it deserves to be on its own free-flying platform in Earth's orbit. Initially we're flying it on the shuttle for a couple of reasons. It's a very complex radar system, the most complex one we've flown to date. It has uniquenesses to it of the multi-frequency, multi-polarization, and things we haven't tried before. We're flying with recorders that are state-of-the-art recorders. They've flown once on the shuttle with a single tape kind of mission, and we're flying 3 of them on board now and running 150 tapes through them at very high rates. So we weren't sure that that would work right. The radar, we'd like to be able to bring it back between flights and modify it and do maintenance on it if we have to. And you can't do that once you launch it into an unmanned platform. You no longer can get hands on it, so to speak. And the other thing is we're still trying to figure out exactly how to analyze all the data that the radar gives us. So one of the big objectives on this mission is to use orbit-based observations, which we've been doing extensively, along with the people on the ground doing concurrently ground-based measurements, so we can start to put all this together into a better computer, algorithm kind of program that we can correlate the data the radar gets back to what kind of image it needs to produce. And there's still some gaps in that knowledge of how to do that. So right now we're using people to help fill in those gaps. We're using the shuttle as a platform to return it to Earth in case we have to make any modifications or changes. And all this should lead to, we hope in the future, a permanently based in Earth orbit unmanned platform.
Are you surprised at how well everything has worked on this mission? I know that there was a report yesterday that about 95% of the Earth that you wanted to map, you'd already mapped by yesterday. I mean, you're way ahead of the optimum schedule, aren't you?
Tell you what, we feel really good. You know, going into the mission, you kind of think, what are your mission objectives? What are you going to be satisfied with? And I think we would have to have said we would have been really happy and satisfied with the lesson we've gotten so far. And so this is really great. The recorders have functioned perfectly. I don't think they've missed a planned data pass, and we've tried to get observations on every one of them. Honestly, I'm amazed it's worked so well because it was a complicated effort to put together. But I'll tell you what, there have been some people on the ground who have spent 1 or 2 decades pulling this project off. So it didn't just happen overnight. People worked very hard on it to make it as successful as it has become.
A viewer in Derby, England, wants to know if life aboard Endeavour is as cramped as it looks like it is on television. How crowded is it in there where you are?
Well, I'll try to describe it, and I have to say it is a little cramped. You know, we have 6 people on board, and we're sleeping in shifts. So right now, 3 of our folks are asleep downstairs in sleep stations. And right now, I'm on one end of the shuttle, one side of it, and this camera's on the other. So you're seeing the width of our flight deck. And the other dimension of it is just about equal to what you're seeing across here. And we have a slightly larger area down below where we have our sleep stations and galleys and for fixing the food and lockers for stowage. But it's pretty cramped. It's kind of about like having 2 medium-sized bathrooms on top of each other in terms of size.
Yeah. Back on Earth, there's growing concern that the International Space Station won't be completed. What would it mean to astronauts and to other aspects of the International Space Program if the space station were canceled?
I think that we'd still like to keep flying. Space Station has been a planned project for a long time. We're still trying to get it off the ground, and we hope it flies. I think the shuttle has proven itself as a great vehicle in orbit for science research, and we've got that at this point no matter what. We have a laboratory module we can fly in the payload bay and do material science and other long-term experiments. We still hope to have a station, and all you can do is... But it's by no means the end of the... If for some reason that doesn't happen, I think we still need to continue to be a presence in space.
One of our viewers, Paul Ragg from Britain, wants to know what you believe the major significance of this mission has been so far, and have you been surprised or alarmed by anything that you've found?
The major significance of the mission, I think, is the place in the big picture of this flight and the mission to planet Earth. It's one of NASA's major projects right now. It came into being officially, I guess, about 3 years ago now, in 1991, and this is just one of a series of projects that is a part of NASA's effort to learn more about our home planet in terms of the atmosphere and the oceans and the land. And I think from a shuttle-based point of view, we've had things that have studied the atmosphere extensively, and we have some of that on this mission with a measurement of air pollution by satellite, our MASS experiment. But we're also concentrating more on the land, which is unique. So that's something I feel good about this mission. I think it's unique in that it is a very intensive Earth science mission. And some of the other things at the very core of it is between people working up here and people working on the ground. So we pulled off a pretty big team effort. And I honestly can't say I've seen anything out the window that's been alarming. In fact, you know, from our vantage point here in space, it's all quite beautiful.
All right, Dr. Linda Godwin, thank you very much for joining us from the flight deck of Endeavour. It's been a pleasure to spend time with you. Look forward to seeing you when you get back. The shuttle is landing at 15:53. Oh, same for me. The shuttle will be landing at 15:53 GMT on Tuesday at the Kennedy Space Center in Florida, and we'll see Dr. Godwin once she weighs something again. Sonia, that's our report.
John Holloman, thank you so much. That was fascinating.
Interesting.
And that is World News for now. I'm Sonia Rister. Thank you for joining us. World Sport is up next.
Bad weather, I'm afraid. The Space Shuttle Endeavour is looking at conditions back on Earth. A major part of its mission is to create a radar map of the Earth, and it's been turning its cameras towards the flooded areas of the Midwestern United States and Germany too. Scientists say radar is the best method in a situation like this. It can penetrate the cloud cover that often covers heavily flooded areas. Now for a more down-to-earth view, it's aiming its high-tech cameras at flooding in Germany and the Midwest. A major part of its mission is to create a radar map of the Earth, and it's been turning its cameras towards the flooded areas of the Midwestern United States and Germany too. Scientists say radar is the best method in a situation like this. It can penetrate the cloud cover that often covers heavily flooded areas.
Sonia, the managers of the space shuttle and the European manufacturers of its high-tech radar system are attempting to use the shuttle to help people on the ground today. Here's some pictures that show the ground around Oberpfaffenhofen, Germany, as it looks to the shuttle's radar system. Even if that area were covered with clouds, the radar would provide pictures this clear as it moved overhead. That's what's happening in the U.S. Midwest and areas of Europe, including Germany, where flooding is a problem today. Scientists on board the shuttle didn't expect to study flood damage from space, but since the weather has caused flooding, the crew was doing its best to help. Here's what the flooded region looked like a few minutes ago as seen by TV cameras in the shuttle's cargo bay. As you can see, it's mostly cloudy. The Endeavour crew has been impressed with how well the shuttle's equipment is working. Payload Commander Linda Godwin talked about it in a CNN International interview.
We feel really good. You know, going into the mission, you kind of think, what are your mission objectives? What are you going to be satisfied with? And I think we would have said we would have been really happy and satisfied with less than we've gotten so far. And so this is really great. The recorders have functioned perfectly. I don't think that they've missed a planned data pass, and we've tried to get observations on every one of them. Honestly, I'm amazed it's worked so well because it was a complicated effort to put together.
Godwin also told us she hopes NASA will keep the shuttle flying even if the International Space Station program is eliminated by the U.S. Congress. The astronauts will stay in orbit until Tuesday. They're planning to land on Tuesday about 1500 GMT in Florida. Sonia?
John, thank you. And that's...
Hello, I'm Miles O'Brien. Whether they are tracking a killer hurricane or a stubborn high-pressure system, the orbiting eyes which make up the U.S. weather satellite network play a crucial role for forecasters. But in recent years, that network has been a bit under the weather. A satellite launch this week should help fill some gaps in the weather picture. But as CNN's John Zarella reports, meteorologists say the system has a long way to go.
3, 2, 1.
The Atlas rocket thundered off the launch pad during the early morning hours Wednesday. Riding to space on the vehicle was a satellite heralded as a revolution in meteorology. The satellite is called GOES-I. It is the first in a series of 5 ultra-sophisticated weather satellites. Built for the National Oceanic and Atmospheric Administration, the spacecraft is expected to provide weather forecasters with an ability for accuracy they never had before.
Will allow us to look with greater precision, greater accuracy, and greater frequency than we have ever been able to observe weather from the geostationary advantage of space before.
GOES-I will more clearly see weather patterns over the entire U.S. It can also focus on areas like thunderstorm cells and hurricanes. That should mean increased lead times for predicting severe weather and hurricanes.
Hopefully we'll be able to narrow down those zones of warnings that we are required to provide, and that the numerical guidance will be improved because of the sounder capability. The higher resolution infrared capability will allow us to better determine where's the center of the storm. We have a lot of problems at night with infrared imagery today, with systems out over the open water.
All this technology has come at an enormous cost. GOES-I is 5 years late. Riddled with design flaws and cost overruns, the 5-satellite program has ballooned from an original $275 million price tag to more than $1 billion, not including the cost to launch.
The biggest problem with this program was too much optimism on the people who began the program, rather than any significant underachievement on the part of the people who finished it.
We also made a mistake as far as the computer capacity was concerned because we totally underestimated the capability of weather forecasting to move forward.
But the Weather Service desperately needs these new eyes. The last of an original group of GOES satellites was lost in a launch mishap in 1986. The one remaining in space has passed its life expectancy. To cover the far reaches of the Atlantic during hurricane season, NOAA borrows a European satellite. GOES-I will be of little use this year. Once in orbit, the satellite and its systems will have to be checked out.
That will take until at least October, about the time hurricane season is winding down. John Zarella, CNN, at the Kennedy Space Center in Florida.
For a while on Saturday, Endeavour's crew turned into high-flying meteorologists. They scanned the huge thunderclouds over America's Midwestern states. Taking all those great pictures, it's a shame that we don't have any to share with you this morning.
Home stretch of its 10-day mission to planet Earth, and the word from 116 miles up is the crew's having great fun seeing the planet spin beneath them.
The last time I flew, I was twice as high in altitude, and we couldn't see the kind of detail we can now. We can see all the small rivers, the small lakes. We can see how they're all changing state right now as we're changing seasons.
Astronaut Tom Jones showed ground controllers an ancient axe discovered in the Sahara Desert using another space radar system. He says that axe is significant because people 200,000 years ago used it to make their lives better.
They were struggling to improve themselves in their struggle against nature, to carve out a niche in the natural environment. And now here we are trying to understand our niche in the natural environment using our latest technology, which is the Space Shuttle and the Space Radar Laboratory that we have on board. And just as always, down through human history, we're using the best tools we have.
Endeavour's radar has given ground scientists something to crow about. This is the Sahara Desert, where Jones's axe was found. On the radar, you can see various channels where water once surged through rivers, long since dried up. These shots show how well the radar can see through foliage on trees. On the left, a shot where trees prevent a close look at a flooded river. On the right, the flooding is obvious in red. The Sierra Nevada mountains are covered with snow and clouds. You can see that on the left, but the radar view on the right shows the snowpack. This is a national forest in Michigan. It's cloud-covered to the shuttle's TV cameras, but from the radar, you can tell much more. This shows how thick the vegetation is. Blue is the thickest, red the thinnest. And another picture shows which kinds of trees are growing in the forest. Blue is spruce, yellow is hardwood, and green is pine. On future missions, the radar will get this same information about forests inaccessible to people. John Holloman, CNN reporting.
This look at the world weather opens up with our Tuesday morning forecast weather map for the European continent. High pressure is still in place, so many places are still going to be enjoying nicer weather than they've seen in recent weeks. But we do have a storm system moving through Eastern Europe and lifting out to the north, and most of the activity associated with this system will be moving to the northeast. As you can see, still even a little bit of snowfall expected along the frontal boundary. The Mistral has been blowing, this low pressure center moving across. We believe that that will weaken somewhat, but we still could see some wind gusts up to 20 knots. And yet another weather system will be moving across the British Isles, bringing in some rain showers as it moves on across. So the forecast in the Great Lakes region are in the northeastern United States. Possibility of a few showers in the northern Rockies too, and as you get up into Canada, we could see a little bit of snowfall. Moving
Endeavour are heading for home. The 6-person crew returning from a successful 10-day mission. They mapped the Earth's lands and waters with new radar designed by the U.S., Germany, and Italy. The advanced system will help environmentalists distinguish between natural changes and those caused by industry and agriculture. The shuttle is scheduled to land at Kennedy Space Center in Florida in just about 2 hours. The time has been delayed due to cloudy weather. CNN International will broadcast the landing live. We turn to bad weather or inappropriate weather there. It had been kind of an iffy shot all day. They will try again tomorrow, and CNN will bring you live coverage when that takes place. The new time for the attempted landing will be 11:29 a.m. Eastern Time. The landing today was delayed because of low clouds over the Florida landing site. We will have live coverage for you tomorrow. Well, Flip's having another one of those days where he's having a hard time justifying his salary.
Oh, wait a minute, let's not get carried away about it. No, not much bad weather out there any place. Matter of fact, warm spring-like temperatures cover much of the nation. We're going to see a change to that in the Midwest. We had a bunch of record-setting highs throughout the Northwest, the West, and here in the Midwest. Now, some of that's going to cool off. You can see the cold front here. Let me run it through one more time. You can see the cold front right here. There it is. See it? So things are going to be considerably cooler in there. We won't see any record highs, but still across the south, the southeast, northeast, picking up a little bit of rainfall now. I think we're going to be another very, very warm and sunny day. The cool air as it's moving to the south is moderating very, very quickly. By the way, this isn't as bad as it looks. A lot of this is not reaching the ground, showing up on radar, but rainfall not getting to the ground. Rain in the northeast is getting to the ground, and there you can see the bad weather in Florida that we were talking about a little bit earlier, too, in regard to the space shuttle. Back to what I was saying just a moment ago is this cooler air, or cold air, really, when it moved down, is moving to the south, moderating very, very quickly. For example, let's take Denver. I said Denver would see a high today probably in the 60s. I think they're still going to make it up around 70 degrees, and tomorrow will be back up well into the 70s. So it's really, really moderating fast. I guess it's late enough into the season that the cold air just can't hold its punch due to the abundant sunshine across this area of the country. A few thundershowers are possible later today along the Texas Gulf Coast. You can see how that front down there will degenerate to nothing more than a low-pressure trough. The cold air continues to push off the east coast, will push to the south, and again, moderate greatly. Will not be a real big cold snap, but will bring to an end the record-setting high temperatures in the Midwest. Could see some showers in the northwest as one little storm after another is trying its best to move in, but this large area of high pressure in the upper atmosphere guarding the west is either kicking them over the top or to the south. It looks like by late in the week we will see another storm come into the west coast. Could even bring some rainfall into Southern California. This will be awfully late in the season for LA to see any kind of rain.
It is the second delay in 2 days. Wednesday's landing had been scheduled for less than an hour from now. Dense clouds and crosswinds prompted the cancellation of Tuesday's scheduled touchdown in Florida. The mission was devoted to studying the Earth and its environment with high-tech radar equipment. CNN International will provide live coverage of Endeavour's landing.
Absolutely, Bobby. Shuttle Commander Sid Gutierrez, in the past couple of minutes, has completed firing Endeavour's braking engines to drop the spaceship out of orbit. Its speed is slowed from 17,000 miles an hour to a slightly slower speed. Endeavour beginning to fall toward the Earth's surface right now. The heat tiles on the bottom of the shuttle are in fact heating. On the ground, the weather at Edwards Air Force Base seems to be perfect compared to very cloudy weather conditions at Florida's Kennedy Space Center, so Endeavour is heading for California. Ground crews are in place at the Air Force Base, and they'll make sure Endeavour is safe before the astronauts get out. Landing is scheduled for 12:54 Eastern Time, less than an hour from now, and we'll all watch it together. Hope you'll be here. Bobby?
John, thanks.
In just a few minutes at Edwards Air Force Base in California, we'll have coverage ahead on NewsHour.
Bobby has some fabulous new technology TV cameras that can show you the space shuttle from pretty far away. Let me show you the live picture that we're getting from NASA right now. It shows the shuttle Endeavour. It's just made its final turn to come down for a landing at Edwards Air Force Base. The shuttle entered the Earth's atmosphere a few minutes ago, and it's red hot on the bottom right now. The insulating tiles are cooling, though, as the spaceship gets close to the runway at Edwards Air Force Base in California. You remember yesterday's scheduled landing in Florida was canceled because of thick clouds down at the Kennedy Space Center landing strip. The shuttle so far has traveled 4.7 million miles since it took off 11 days ago. It has circled the Earth about 180 times. The one-woman, five-man crew has snapped more than 14,000 still photographs of the Earth and has recorded hundreds of hours of computer tape filled with radar images. I'll stop talking from time to time to listen to the crew members talk to NASA controllers on the ground, but they're right on the glide slope that they're supposed to be for their landing. Over the next 12 months, those radar pictures and images will be released to the rest of us, and space agency scientists say they'll have a much clearer picture of planet Earth after this mission is over. After it touches down in California in just a few seconds from right now, the Endeavour will be loaded aboard a 747 airplane, and it will be flown cross-country to the Kennedy Space Center in Florida. During the last couple of seconds of the Endeavour flight, we'll just listen and hear what happens as it touches down in the California desert at Edwards Air Force Base. Wait for the nose wheel to touch down. There comes the drag chute to slow Endeavour. Looks like it's rolling to a stop. Endeavour has no engines like a normal airplane, so it's the sound you're hearing there is just the wind whipping over the wings and through the parachute. Getting the space shuttle back to Florida will cost us taxpayers about $1 million. It's going to Florida to be refurbished, but the payload bay, behind where the driver and the crew live, will stay about the way it is now. The space radar will fly again on the same shuttle in August. That will give scientists a look at the planet in summer, as well as the look that they've just completed of the springtime world. Now that Endeavour is down, the launch team will take a little time off. The next shuttle flight won't come until July.
Wheel stop. Roger, wheel stop, Endeavour. Sid, your radar laboratory has provided an unprecedented view of our planet, and you and your crew have been a joy to work with. Welcome home.
Thanks. And we've enjoyed working with all you folks at MCC. It's been great. And for all the payload people, we appreciated working with them, and all the years of hard work has paid off.
That was Sid Gutierrez, the Endeavour commander.
Endeavour, thanks for those words. There are no post-landing deltas. You got to go to start on page 5-3 in the entry checklist.
What that means is the crew can take off their heavy flight and landing suits and get ready to step outside the shuttle. The next shuttle, by the way, won't fly until July, when Columbia will keep NASA's International Microgravity Laboratory in space for the second time. That 2-week mission will give medical and chemical scientists some new tools in medicine and industry. Then, as we said, it's Endeavour again in August. A September launch will include a spacewalk by an astronaut testing a new backpack for flying around without being attached to the shuttle. And in late October, the Atlantis shuttle, which has been in the repair shop for months, will rejoin NASA's fleet for a science mission to examine the Earth's atmosphere. NASA hopes to fly 8 shuttle missions this year. Again, the next scheduled shuttle launch is July 8th, as Columbia spends 2 weeks on medical and chemical research. So this mission of the Space Shuttle Endeavour, delayed or rather increased by 1 day, is now at an end. The astronauts will be getting some medical checkups and get back to work. John Holloman, CNN reporting.
Thanks, John. And that's it for NewsHour. I'm Jean Meserve in Washington.
And I'm Bobby Batista in Atlanta. Here's...
Endeavour um 18:54 Uhr auf dem Luftwaffenstützpunkt Edwards in Kalifornien. Dichte Wolken hatten die Landung in Cape Canaveral in Florida zweimal verhindert. Die 6 Astronauten an Bord, 5 Männer und eine Frau, hatten auf ihrem 11-tägigen Flug mit einem neuen Radarsystem Teile der Erde kartografiert und mit einer herkömmlichen Kamera tausende Bilder geschossen. Damit sollen unter anderem Umweltprobleme, die sich zum Beispiel durch Abholzung ergeben, analysiert werden.
Space Shuttle Endeavour returned to the planet on Wednesday. The mission was a cartographer's dream, offering an unprecedented new radar survey of some regions of the world. As CNN's John Holloman reports, the survey will lead to detailed 3D maps of the Earth's surface.
2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
When Endeavour was launched after equipment and weather delays, there was worry its high-tech equipment might not work. But those fears were quickly put to rest as the radar started sending dramatic pictures of Earth back to scientists on the ground. The astronauts had few problems to solve in space, and they spent almost all their time pointing cameras out the windows. Back in the cargo bay, the radar was whirring and sending images like this one of the Sahara Desert back to Earth.
He has seen this image, and he's just ecstatic. And I know it's hard to believe, but the PI tells me that everything we're seeing here is covered by sand.
An earlier space radar mission found the lost city of Ubar in this part of the Sahara Desert. Astronaut Tom Jones brought an Ubar artifact with him on this mission. He says there are similarities between the axe maker and the astronauts.
They were struggling to improve themselves in their struggle against nature, to carve out a niche in the natural environment. And now here we are trying to understand our niche in the natural environment.
Linda Godwin is payload commander. She told CNN Endeavour's radar images surprised everyone.
We would have been really happy and satisfied with less than we've gotten so far, and so this is really great. There have been some people on the ground who have spent 1 or 2 decades pulling this project off, so it didn't just happen overnight.
The ground-based scientists analyzing the pictures couldn't be happier.
We've gotten tremendous response, and everything is going so well. It's we're just so excited, it's almost difficult to put into words. I think the best phrase sums it up is that our success has been beyond our wildest dreams.
The astronauts' dream mission is one with their noses pressed to the windows. So pictures like these of Africa, South America, and Saudi Arabia in daylight, and lightning storms in the U.S. Southwest and Midwest in darkness were mission highlights for the Endeavour team. The same sort of weather that delayed the launch kept Endeavour in space for an extra day. The shuttle did finally come back to Earth 11 days after leaving at Edwards Air Force Base in California.
The next shuttle mission isn't scheduled until July.
The countdown has been going smoothly overnight. We have not been working any technical issues since the tanking began at 11:09 last night. Loading the Space Shuttle external tank with the 525,000 gallons of liquid hydrogen and liquid oxygen was concluded at 2:05 this morning. Once again, all our countdown events are proceeding normally, leading to an opening of the launch window at 8:06. We're cautiously optimistic about the weather. We're now at the astronaut quarters in the operations and checkout building at the Kennedy Space Center, where the STS-59 cake is in the center of the table. Mission specialist Linda Godwin down at the end of the table, and sitting next to her, mission specialist Jay Apt. Linda Godwin and Jay Apt working on the Space Radar Laboratory during the flight. And next to Jay Apt is mission specialist Tom Jones, who will also be flying on the Space Shuttle once again in August on the next Space Radar Laboratory mission, SRL-2, again on Endeavour. Our pilot Kevin Chilton, and sitting next to him is our commander Sid Gutierrez, and then on the far end is mission specialist Rich Clifford. This is shuttle launch control at T-minus 3 hours and counting. The countdown has picked up once again for the launch of STS-59 and Endeavour, and all of our activities are on schedule this morning. We're cautiously optimistic about the weather. The broken layer at the shuttle landing facility is expected to go scattered sometime after sunrise, so we're still hopeful that if the wind does not become any stronger than it is currently, that we will have a launch this morning. Among the tools that the ICE team is using is the portable infrared scanner. That's the most important device, which obtains temperature measurements on the surface of the vehicle, and can also spot any leaks. And they're looking for any ice which could be on the tank or other areas of the fixed service structure, which could, at launch, could break off and strike the orbiter. This is shuttle launch control at T-minus 3 hours and holding. Our commander, Sid Gutierrez, outfitted there with his communications hood. And final fit check of the helmet. And our pilot, Kevin Chilton. He flew previously on the STS-49 mission. He's ready to go this morning. And there's our payload commander, Linda Godwin. And mission specialist Rich Clifford. Tom Jones, mission specialist, who will be flying again on Endeavour in August on SRL-2. Astronaut Dave Leesma there talking with Jay Apt. This is shuttle launch control at T-minus 2 hours, 51 minutes and counting. Our commander Sid Gutierrez, followed by mission specialist Tom Jones. There's Jay Apt, Linda Godwin, Rich Clifford, Dave Leesma, and Hoot Gibson also riding down the elevator. He'll be flying the shuttle training aircraft this morning and the T-38 for weather reconnaissance. Mike Stevens from NASA Security, leading the crew as they come out. And they'll leave Gibson off all the way to the pads. And away they go. Find it quite pleasant out at the pad this morning. The temperature is 72 degrees with winds out of the east-southeast at about 10 to 15 knots. Aboard Endeavour, helping the crew again today is astronaut Andy Thomas. He's been in the crew compartment, configuring the switches, making any changes necessary to the compartment, and will be assisting the astronauts as they board.
Endeavour CDO, reads loud and clear. TLT loud and clear. MS1 loud and clear. MS2 loud and clear. MS3 loud and clear. MS4 loud and clear. ECL, here's step 828. For step 828, cabin pressure reading 14.85. Copy that. That's steps 826 through 832. And CDR, you can go ahead and reconfigure BFS memory. Roger. And CDR OTC, go to close cabin vent valve. Roger. This is NTD taking a launch status check. Say go, no go for launch. OTC, go. TBC. TBC's go. TTC. TTC's go. LPS. LPS is go. Houston flight. Go. Mala. Mala's go. STM. STM's go. Safety console. Safety is go. SP. SP NTD. Go ahead, NTD, SP. Go, no go for launch. Go. CDR. Endeavour crew is go for launch. LRD. LRD is go. And SRO.
SRO is go. You have a range clear to launch.
Copy. Endeavour OTC. Close and lock your visors. Make O2 flow. And Viacon Dios.
Roger, thanks a lot, Mark, and we'll see you in about 10 days.
Copy that.
T-minus 45 seconds, standing by for the handoff to Endeavour's onboard computers in about 10 seconds at T-minus 31.
TLS is go for auto sequence start.
Endeavour's computers now controlling.
25. 20. 15.
Sound suppression water system being activated.
10. TLS is go for main engine start.
7, 6, main engine start. 5, 4, 3, 2, 1, 0, and liftoff of the Space Shuttle Endeavour, observing the changes of planet Earth.
Roger, roll, Endeavour. Houston now controlling, Endeavour rolling on course for 57 degree inclination, 120 nautical mile orbit. Endeavour already traveling about 300 miles an hour on a course that will have it go northeast above the Atlantic Ocean, parallel to the eastern seaboard of the United States. Endeavour speed now 1,000 miles an hour, 5 miles downrange.
Endeavour, go at throttle up.
Roger, go with throttle up.
Altitude 9 miles. 3 engines now back at full throttle. 1.5 minutes since launch, Endeavour's already burned more than 2.25 million pounds of propellant and weighs less than half of what it did at liftoff. Altitude now 15 miles. Speed 2,100 miles an hour, 15 miles east of the launch pad. Flight controller standing by for burnout and jettison of the twin solid rockets. Good solid rocket booster separation confirmed. Endeavour now 33 miles northeast of the launch pad. Altitude 30 miles. Speed 2,700 miles an hour.
Endeavour, performance nominal.
Copy, performance nominal.
T0, SRB ignition.
Liftoff confirmed.
Copy.
Roll program, Houston.
Roger, roll, Endeavour.
Flight guidance, see the roll.
Copy.
Throttle up, 3 at 104.
Endeavour, go at throttle up.
Roger, go with throttle up.
Endeavour Houston, we see a nominal MECO, ohms 1 not required. You have a go for the ET photo DTO.
Roger, that's in work.
Flight Capcom.
Go ahead, Capcom.
I'd like to get the AOS and LOS times for Diego worked up to add to the spiel I'll give him for LOS and AOS from the east and the west.
Stand by, Taco.
And Taco, standby 1 on the note for Chile. I want to know, do you want me to select an item 17 there in line with stars 29 and 22 as they are in the table, or you want me to clear the table and get them again?
Roger, we're checking.
Flight GNC.
That sounds like another PhD subject from science. Oh, see, this shows I'm great. Become a TV.
Is there any doubt?
Same thing.
And we've got a good picture, Rich.
Okay, Bill, what you're seeing is some live cells growing in the space tissue loss B experiment. STLB, along with its companion STLA, are growing live cells in the microgravity environment to evaluate the effects of microgravity on the growth process. The novelty of STLB is it's making its maiden flight to check out a new video microscope system, which is going to allow real-time monitoring of the cell growth process in microgravity. To check out the system, fish eggs are being used to watch the development of the embryo during early division stages. This is going to evaluate if changes in gravitational force have an effect on cell movement in 3 dimensions. Experiments like this should provide unique insights on the effects of physical forces on cell movement and may provide clues to the understanding of how wounds and organs develop. Okay, Nancy, we'll turn it over to Sid.
Sid Gutierrez, commander of this SRL mission, and this morning I'm going to try to do my most difficult task of the entire mission, and that is to attempt to explain zero Doppler steering. During the course of this mission, we've been initiating approximately 460 maneuvers. In fact, this morning, we just initiated the 262nd of over 460 maneuvers. By the time we finish this flight, we will have initiated more maneuvers than any other shuttle mission. These maneuvers are very important because they help us point our radar in a very special way. In our normal attitude, we fly around the Earth with either our nose forward or our tail forward with the payload bay radar pointed at selected sites. We produce a radar image by sending a radar signal which is bounced off the Earth and returned to an antenna in the payload bay. Scientists use very powerful computers and very complex software to process this radar data in a very special way to produce what we call a synthetic aperture radar image. In fact, just this morning, they transmitted up to us on our TIPS machine a picture of a radar image that was taken of the Galapagos Islands. Just yesterday. Probably hard to see this on the television image, but this was created with the radar image. This very complex processing assumes that the orbiter is parallel to its ground track as it travels around the Earth. You can see that for an Earth that does not rotate, an Earth that's perfectly still, this is probably true. But we all know that our Earth rotates. So as the orbiter goes around the Earth and the Earth rotates, that means that our ground track and the orbiter are not perfectly aligned. And I've exaggerated this a little bit for demonstration purposes. We can make them aligned by constantly maneuvering at just a fraction of a degree per minute, so that as we fly around the Earth and as the Earth rotates underneath us, our orbiter is always aligned with the ground track that we trace across the ground, which is what is really important for the radar. We call this zero Doppler steering.
And this is one of the types of consumables that sometimes can limit flight duration. We, of course, have plenty stored for our mission. And they're very large filters that fit in, that are inside some protective covering that we have to remove before we put them down into the air purification system. And this is done at the end of each of our shifts, the red shift and the blue shift. So we swap out sometimes one and sometimes 2 cans twice a day. And as this is removed, we very carefully save the tape we're peeling off and the covering, and we put the used cans back in that and store them back in the same area. And sometimes we know that we can come back and get some of those out again if for some reason we need some additional
purification capability.
Hi, I'm Sid Gutierrez, commander of the Space Shuttle Endeavour. This message was recorded in April as we were orbiting the planet, studying the surface of the Earth and the atmosphere above it. As we image the surface of the Earth with our radar and visual photography, we've noticed certain rectangular patterns all over the world. More and more of these patterns are appearing in the United States. On closer examination, we realize that these are soccer fields. More people are playing soccer than any other sport, and for the first time in history, the World Cup is being held in the United States. So from way up here to all the participating countries back on Earth, welcome to World Cup. Good luck, but watch out. We're even working on a team up here.
You let it in! Score!
More head bouncing? There's the payment. A little more bouncy off.
How about elbows?
Come back down. Remember, it's going to always ricochet off something. Sort of a closed volume.
W5RRR, this is N5REX. I'm receiving loud and clear. You know, it's exciting and all to be up here in the shuttle. There's no denying it. And the views are just beautiful. But the thing that really makes you feel good is to know that all those people that worked so hard, so long to make this work,
pictures out.
It's coming together for them. That really makes, brings a tear to your eye. It's such a happy feeling, over.
At Houston Endeavour, for those watching Sid, he's talking to the Boy Scouts of America down in Richardson, Texas at this time on our Shuttle amateur radio experiment, basically a ham radio, and answering questions that the Scouts have lined up for him.
And Bill, I don't know if you can see over this far, but here's the visual function tester gear that Sid and I are doing once a day, and I hope I'm off the test.
Oh, am I just on the ground? No, I'm in the seat there.
And thanks, Jay, we copied, and we will have TV for approximately 7 more minutes.
Now, the seat moving on you, Tom?
Yeah.
Does the seat extend over to the
maybe
VFT?
the back.
Yeah, the seat should be firm now.
Oh, I'm sorry, Sid.
Oh, I'm
Yeah, it just slipped back. I need to move it up.
Oh, you need to move forward?
Let's slip back. It's just all this force that's being applied.
Put your body where you want it.
Right, I am.
Right there?
Yeah.
How's that?
Okay.
Good morning to everyone back there on the Central Time Zone. I'm Tom Jones, mission specialist aboard the Space Shuttle Endeavour. We're now over the South Pacific Ocean, just southeast of New Zealand. I want to take a few minutes out of our busy schedule up here of maneuvers and science operations to tell you about our studies of global change on this mission. This mission of the Space Radar Lab aboard STS-59 on Endeavour is part of NASA's mission to planet Earth, which is a comprehensive program using the space shuttle and unmanned satellites to study the Earth as the next century begins and to understand the changes that are going on, both natural and man-made. Now, I'd like to tell you about our experiences here for the first 4 days of the flight. We've been seeing traces of both man-made and natural change. Spring is coming to the northern hemisphere. We can see the snow line retreating across Asia, and we're seeing vegetation patterns, land use changes, natural changes caused by weather and geology, like volcanoes and earthquakes. We're looking for all those kinds of phenomena. I'd like to tell you about why we're able to study global change from the space shuttle on this flight. First of all, I want to mention our vantage point up here in orbit above the Earth, what the Space Radar Lab out in the payload bay is looking for, and then give you some examples of the kinds of change that we're hoping to study on the flight. Now, our vantage point here aboard Endeavour is very important. We're about 138 nautical miles above the Earth's surface, circling the globe once about every 89 minutes. And that elevation, that altitude, gives us a horizon that's out several hundred miles from wherever we happen to be over the Earth. And that gives us the broad perspective and the ability for our sensors in the cargo bay to see a long distance and measure change in a reasonably efficient amount of time. Also, because we're in orbit, our speed is very important. Circling the Earth at 17,000 miles an hour, we're able to use our speed to let our radar out in the cargo bay, Cersei XR, create a much larger electronic antenna than would otherwise be possible. We can see finer detail on the ground because of our speed across the Earth's surface. That whole technique is called synthetic aperture radar. And also, with our pollution sensor called MAPS in the cargo bay, our speed permits us to cover the world as it rotates beneath us, and thus we can create in just 2 or 3 days a global map of carbon monoxide, a tracer gas of pollution or burning on the planet's surface. So the vantage point here is very important. Now, what kinds of changes can we see from this vantage point in low Earth orbit? Our synthetic aperture radar creates images, pictures of the ground using microwaves, which can be taken during darkness or through clouds. The MAPS carbon monoxide sensor creates a map of global pollution. It traces sources of combustion and how that trace gas, CO, spreads across the globe. Now, using those images and that pollution map, we can look at Earth's past, present, and its future. We can look back into Earth's past by noting changes in the geology of the Earth that tell us about the world's past climate. We can look at the present and take a snapshot, a baseline measurement, if you will, of the pulse of Earth's forests, cities, our production of pollution in both hemispheres, and we can also measure the ecology, the environment, and take its present temperature, if you will. And now we can look into Earth's future by flying the Space Radar Lab twice this year on STS-59 later in the year, and later radar of this type and a similar suite of instruments could be orbited on an unmanned platform. And by measuring Earth's environment over months and years, we can see the trends on our ecosphere that would help us manage the planet in a better and more careful way.
Okay, Nancy, what we did was earlier today we recorded us doing what we're here for, which is to do a large number of maneuvers to point the radar exactly at the targets that the radar folks are interested in. And we understand from the radar people that they're getting accuracies that are far beyond their initial expectations, and the targets are showing up right in the middle of their radar swaths, and we're real happy to be able to help them do that. Here we are putting in one of the 460-some maneuvers that the ground has planned for us, and it's a real pleasure to be able to go do that and see the results like the radar folks have been showing people down there, and know that we're able to point the orbiter extremely precisely to get very specific targets within range of the radar beams from all of the equipment out in the payload bay. This is what we spend most of our time doing, and what I think you guys have been really helping us check.
We're just now coming upon Chile after passing across the coastline. And the target area for this observation is the Andes Mountains, Central Cordillera area. Dr. Isaacs is mapping the topography and studying the climate in the Central Andes Mountains. He's mapping things such as plate tectonics, or the movement of the Earth's crust in this area, as well as mudslides and other climatic events. This image is of Sicily. This is a real-time image seen exactly as the radar system aboard Endeavour records it. And now Endeavour's radar is crossing the coast of Italy. This is the most southern tip of Italy here. The Matera, Italy calibration site is located in a very flat agricultural area. And the wavy lines in the image are the former Yugoslavian territory, Eastern Europe.
Well, this is a view from one of the off-payload bay cameras showing the radar and zooming out from the cockpit over to the Earth. This is on a pass we did earlier today over Central Europe. You can see the KU band antenna lit up there, and that's how a lot of the data that you're seeing real-time down on Earth gets down there.
Okay, Jody, we're over. We're getting close to the water here in the Labrador Sea.
Okay,
It looks pretty clear today.
Great. We're all listening.
We're seeing some clear areas out there and some sea ice, and there's some sun glint chasing just ahead of us on the sea ice that Chile's trying to shoot right now.
Okay, we're seeing the XR come down and see the ice looking as large floes that are breaking up.
That's exactly right. There's some very large sections and then kind of wavy-looking pieces where we can see clear water in between.
We see those right now. The leads are showing up quite clearly. We have a video that we'll show you next, which is a view of the Earth along the across Canada, and you'll see both the Earth as viewed by the astronauts through a video downlink and the Earth as viewed by the radar. And this is coming across the screen now. You see the white areas on the right are frozen lakes. In the radar image they appear black, and the bright areas in the radar image on the left are forests. This is a time of year when thawing is occurring, and in the early part of the mission the astronauts were calling down that all of these lakes appeared nearly completely frozen, and now today they're calling down that some of the ice is starting to break up, and so we're pretty excited about this. This means that we might capture the thaw in these high boreal forest regions.
This is a real-time image coming down from the synthetic aperture radar. The site that is currently being tracked is of the Netherlands region of Flevoland. The orbiter's again moving to the southeast. This is a calibration site of high interest primarily because of its it was artificially created by the Dutch, and it allows for easy interpretation of the radar data once it's obtained here on the ground.
These are the German Alps showing up now on the radar. Now we're approaching the super site at Oberpfaffenhofen, Germany, where the 24 locations with their active radar calibrators are set up. And the Munich airport passing right below. Oberpfaffenhofen is just outside Munich. And the Danube River now in the picture.
Before sunrise on the California coast, but the radar can see through that as the California coastline comes into view. On a northeasterly track, Endeavour will cross the coastal ranges, which are mountains that are made from various fault lines. Should also cross over the San Andreas Fault just before the San Joaquin Valley, which is coming into view, a large agricultural area. The orbiter is now crossing the Sierra Nevada to the Mammoth Mountain area, which is a backup super site, which is on the eastern part of the Sierras. As mentioned, this is a hydrology site. The interest here is for the snow cover and the amount of snow cover in that area because of the production of water that the Sierras produce for the Southern California area.
What you're going to see in a minute is a Circe L-band image of Death Valley. Death Valley is one of what we call our super sites. In front of you, you can see the Long Valley, which is the dark area at the center of the image, and on either side you can see the high ranges. Now, a lot of you may be familiar, we produced some similar videos for the Magellan mission. We start out here in the Cotton Ball Basin. The bright, rough surfaces that you see are salt deposits along the bottom of the valley, and also some of the rougher, rockier surfaces. Now this is L-band, which means that the bright surfaces that you see are produced by sort of rubble-sized or medium-sized blocks. Now we're flying down through Death Valley. The smooth deposits you're seeing are some of the relatively smooth salt deposits on the floor. and some of the smoother fans. Now these fans that are coming down from the sides of the valley are produced by much wetter periods in history. What we're trying to understand here at Death Valley with this radar data is what can these alluvial fans tell us about the past climate history of the Earth.
And the coastline coming into view, vision from the synthetic aperture radar as Endeavour crosses the coastline of North America up just above the state of Washington. The data take is of the Juan de Fuca Strait, which is off the coastline, and this is an oceanographic data take for the radar system. Again, designed to observe surface and internal waves as well as wind motion at the sea surface.
We're using 14 cameras on this flight. 35mm cameras, Hasselblad cameras, TV cameras out in the payload bay, a movie camera, and this big 4 by 5 inch camera. All right, now this just short clip here is far northeastern Asia on the mainland passing out to sea. And you can see on the video here the coastline of Sakhalin Island, and it's very snowy still in this part of the world as winter ends. And there is some sea ice all along the island of Sakhalin up through the Sea of Arcot that the radar is imaging for experiments on the penetration of the radar into the ice field. And you can see frozen lakes and ponds in the tundra region up here. And in particular, one of the calibration sites for the radar mission to evaluate the performance of the radar beam, its strength and signal intensity, and its and the ability to aim the radar accurately is Sarabetsu, Japan. And that calibration site is coming into view right here. You can see some of the snow-capped peaks around this area of the coast, and then the street pattern there just to the northeast of Sarabetsu on the coast of Hokkaido. And there you see us passing out over the east coast of Hokkaido into the Pacific Ocean.
It's a site that's of a lot of interest to a lot of people because this is a area of the Aral Sea that used to be the 4th largest body of water in the world and is now shrinking tremendously due to taking the water for agricultural irrigation of the cotton fields down in Kazakhstan. And in fact, the area just to the top of your screen there, I'm sorry, to the bottom of your screen, has a number of fishing boats that are left high and dry 30 or 40 miles from the water. Used to be an enormous commercial fishing area, but now it's drying up, and there are predictions that if things continue at the current rate of diverting the water, the whole Aral Sea will be dry by the year 2020.
This is Mission Control. These views are from Endeavour's payload bay cameras as it flies down across the southern Pacific Ocean. On this orbit, it will pass just slightly north of the tip of New Zealand.
Endeavour is on a southeasterly track now out over the Atlantic Ocean just after crossing over the coastline of the east coast of the United States. The orbiter is in a nose-forward position with the payload bay of the orbiter pointed toward Earth.
Endeavour Houston, we're live on the flight deck. Endeavour Houston, New York City sure was impressive.
We're enjoying it too, Mac.
Yeah, Bill, we just got a beautiful pass up the Hudson River in Fall West Point.
Yeah, Rich, I'm trying to tell Brent he should have gotten here just a couple minutes ago and maybe seen that other school further down the coast.
Endeavour SRL, no response, but your go for tape change on recorder 3.
Yep. I was able to hot wire around that night.
So does anybody have any spare salt panels?
Yeah, I do.
Which was not really used, Tom?
Yeah, I have a surplus.
Okay, I like that.
What a deal. See, I didn't get to see this last time.
Instruments.
Daylight instruments. Oh.
This is impressive.
This is a wonderful country. Breaking at 8 down to 50 knots. 35 knots, easing off. Right on the center line, buddy. 20 knots. 10. Wheel stop. We'd be home.
All right! Way to go, guys.
That was beautiful.
Good job.
Damn straight, that was good. How'd it feel, bud?
Felt good, a little fast.
Ah, it was fantastic.
Right. It felt smooth to me. Houston Endeavour, wheel stop.
Endeavour is about to get onto the heading alignment circle and will begin executing a 285-degree left overhead turn to align the vehicle for a landing on Edwards runway 22. At about 57,000 feet. Traveling at 875 miles an hour, descending at about 300 feet per second. Now below 30,000 feet, 530 miles an hour.
Endeavour on energy at the 180.
Copy, on energy at the 180.
Endeavour, you're on glide slope on center line, surface wind 360, 2 peak 4.
Roger. Houston Endeavour, wheel stop.
Roger, wheel stop, Endeavour. Sid, your radar laboratory has provided an unprecedented view of our planet, and you and your crew have been a joy to work with. Welcome home.
Thanks.
Fido, still on glide slope and center line? Yes, sir. Copy.
Endeavour, you're on glide slope on center line, surface wind 360, 2 peak 4.
Roger.
Copy.